So hi, my name's Sam. I work in Sydney with Chris on the developer relations team, but unlike Chris who works on Android, I work on the web. So we have a small team in Sydney, about 10 of us, but we're all split across different, I guess you call them verticals, which makes me feel dirty inside when I say that word, but you get the idea. So some of us work in cloud, some of us work on maps, some of us work on Flutter, but for us it's web and Chrome. So without further ado, let's get started. I have two topics tonight. Thanks to Mike, I'm going to blame him for that because I was on paternity leave when he proposed this talk, and I just said, sure, whatever. So we actually have two mini talks, one on PWAs and one on web components, both of which Santa use. So firstly, Chris covered this a little bit, but here's Santa Tracker. It's quite cute. You've probably all seen and love this experience on the web. It's quite nice. It's a very playful village. Stuff's happening. You can hover over each house and play a game. So this is what it looks like. It's quite nice. It's on a bunch of surfaces, as well as the Android app, which you probably all know. We actually work pretty well on touchscreens with mouse input. We also on the web work on mobiles really well, so all our games work no matter what screen size you have, which is occasionally a pain in the ass. We also occasionally support Chromecast. The joke is every other year Chromecast works, and every other year I guess it's broken. We get a lot of people mad at us about that. Funnily enough, they leave bad reviews on the Android app because that's the only place they can review things. So we kind of don't get the flack. We get it indirectly. But Santa flies around the world. You can see where he flies. A lot of this talk is not about the tracker, even though obviously a lot of our users come to our experience just to see where Santa is. For us, like, the development time is a bit split. We probably spend way more time on the games and the experiences, as Chris can probably attest to as well, but our users are about half-half. I won't give you the numbers, but about half our users come on December 24th or thereabouts to see Santa, and about half our users come throughout December to play the game and have a bit of a good time. So, as well as being on lots of services, we get warm and fuzzy feelings when we see tweets and photos like this, where we see classrooms and kids playing Santa Tracker. It makes me feel nice and happy that I'm helping people rather than just writing video games that are wasting people's time. The other thing that's really nice and interesting is that we see different uses throughout the year. One thing we've actually just noticed is in 2019 we've got huge spikes during the week, and we think this is actually correlated with classrooms using Santa Tracker more and more. And so what's happened is we've had these weekly spikes, and then as soon as the US summer holidays have started, they've dropped. So we really think that, especially in the US, basically they're continuing to play Santa Tracker games even when they're in class. And some of them, because they're coding games, we don't feel too bad about that. So firstly, the first part of the talk is about PWAs. And so PWAs are invented as a totally invented buzzword that helps you describe what you're doing. So PWAs stands for Progressive Web App. For us, for Google, what it really means is three things. You build a web experience, and we want us to do these three things. We've got these little icons that kind of represent the actions, things that we want to happen in a PWA. First is offline. So you see, when you're online, you have an experience. And when you're offline, maybe on a plane or something, you have a similar experience. This basically means that your website should feel app-like because when you start it offline, it should just work. For Santa Tracker, this is pretty easy. You want to play the games when you're offline, and that's supported pretty well. Secondly, it should feel snappy and responsive, yet again, more app-like things. And lastly, we want it to be kind of interactive and feel more like it belongs on a phone necessarily, rather than just being a pure website. The kind of implicit examples you have here on the right is things like notifications and being on the home screen and being launched full screen. And so Santa does that, which I'll get to in a second. When people think of PWAs, and when you tell your boss you're going to build a PWA, which is kind of one of the things I want to get to, this is why PWA is a thing, right? It's just this concept you pass around to say, this is what I'm building, this is an amalgamation of ideas. But when people think of PWAs, they think of this installed experience. So obviously you can download apps from the Play Store, but on your phone and even on desktop now, you can now install Santa Tracker or sort of similar apps. And you might get prompted in a bunch of ways, which I'll show off in a few slides. But this is really the holy grail of when you're building web experiences, this is what people want to see. They want to see this Santa Tracker application, because it feels like an app, it shouldn't matter that it's a website, on someone's home screen where they can just access it really easily. Santa Tracker is quite a successful PWA in our minds. So of users who use Santa, the web experience, not the Android experience, on an Android phone, about 10% of all launches are done through this home screen icon. So that seems relatively low, but we think these are the most engaged users. They're the ones who have seen that install prompt, which the website has given them, press that button, and are coming back to the web experience on their phone every day, or however often. And so no matter what sort of app you're building on the web, this is kind of what you want to see, right? Like you want people's mind share, because you want your application to be on someone's home screen, ready to go, even if they haven't installed it from the Play Store. Under the hood, how does this actually work? To be a PWA, to get that prompt to be on someone's home screen, you need to do a couple of things. You need to build what's called a service worker. A service worker is a script that's not like your regular JavaScript that runs on your web page, but it runs in the background. And so it's a long-lived script that can basically imperatively intercept network requests. This lets you basically, most people's service workers are pretty simple. They say, if I have this asset, serve it from my cache. If I don't, go to the network. Pretty simple. But there's a few nuances there, right? Like Santa Tracker is pretty static, but if you're a news site, you don't want to serve your front page from the cache because the articles have changed. So you might, go to the network. If it fails, you might serve from a cache. There's a classic example of The Guardian a couple of years ago in the UK would serve a crossword if you're offline. So if you went to their icon on your home screen and you're on a train or on a plane or something, The Guardian would say, well, my articles are out of date, but would you like to play this crossword? And so there was a nice story, right? People shared that pretty well, and you can Google for that experience and how they did that. The other thing you need to do, pretty simple, is provide a thing called a web app manifest. This is really boring, but it's just a file you've got to provide, which tells a phone or even now a Mac, a Chrome OS, or Windows machine how an app might be installed to that user's device. This is no different than writing a manifest and specifying some icons on Android. What you'll get when you do these things is you'll get these prompts. And so, bit of an old photo from 2014, but you'll see something like this on an Android app. When a user visits your site a couple of times, it's not immediate. They'll get prompted to install their app to the home screen. And this is the exact flow that people using Santa Tracker might see, and that's the reason they have that icon on their home screen. Unlike the kind of egregious "do you want notification" prompt, which everyone knows and hates on the web, we're sorry, I think, this prompt only comes a couple of times after you visit. I'm honestly not sure why we didn't take that approach for notifications, but certainly at the home screen we decided, look, if you come back, I think it's twice in 2 days or something like that, we'll allow a website to show this to you so that then users can re-engage with that. It's intentionally a bit fuzzy. Different browsers have implemented it differently, and so for Chrome at least, it takes 2 or 3 loads before this prompt shows up. Additionally, you can actually eat this prompt. So Chrome will tell you what's happening, and you can put it behind a button. This is actually quite nice. So if you have an engaged user, you can hide that little dialogue and instead put it behind some part of your UI that makes more sense. Although the user might be less surprised about. It's not this weird thing they're dismissing from the system that they hate, right? A pop-up, but it can be front and center that lets users press that button to install. What are the challenges of us being a PWA? Like an Android app, we now have kind of an install step. So we don't want to install all 250 megs of Santa Tracker. I don't know why we're bigger than the Android app, but I guess we have more random assets. I'm not really sure. But I did the size comparison, it's quite large. We don't install all of it at once. In a similar way to what you just heard about, we download the core of the app, and then as you play a game, we'll basically try to keep that game up to date. So let's say you go to the village, that's fine, that actually counts as a game for us. Everyone goes to the village. So if we then release a new version of Santa Tracker, which we occasionally do throughout December because we have bugs and we want to fix them, your client will go, cool, they've been to the village. Let's get all the new assets or the changed assets from the village. Because we're doing it programmatically in the service worker, what we basically do, and there's an article if you are curious about this, which I wrote a couple of years ago, is we basically have a hash manifest. We basically generate a file which says this file has hash blah. If it matches, we keep the file. If it doesn't, we throw it away and we go and fetch the new resources for that game or that scene. If you're curious, I wrote another article a couple of years ago, which is basically reasonably high rated. The web app manifest is not the core part of PWA, but it's a really simple thing you can do so that people do add you to your home screen, they get a nice experience. So when that dialog shows up, and this article also covers some of the rules around how that dialog shows up, because like I mentioned before, when you tell your bosses, when you pitch to whoever, you're going to say, I'm building a web app. They go, well, okay, great. How do I get on someone's home screen? This is the answer. You do these things, and then you'll get that prompt saying, do you want to install my app? And that's great. That's what you want, because you want users to be able to go click on that, and you want to have people's mind share, more than just being a bookmark or something in their history. So with that, it's kind of about PWAs. I've covered that. How long is that so far?
About 8 minutes.
Great, perfect. Chris's timer is still going, so I'm going to blame Chris for that. I want to talk a little bit about the way the Santa website actually works, and then I'm going to segue into web components, which is a technology we use which you might have heard of, but I'll get to it in just a second. Santa on the web is kind of what you might think of as a single-page application. It uses web components for mostly the UI and the app shell and things like that, like the sidebar, the menu bar, the other sort of UI stuff that we have. For instance, when you pause a game, we show a pop-up dialog, which is not provided by the game, but it's provided by the core UI. Why do we do Santa? Well, it's to show off a bunch of web technology. As you probably realize, we want to show off new technologies and new features. Things we've shown off include things like web share, this PWA stuff, and I'm sure there's more, but they're escaping me right now. The flip side of that is we've got these games which some people wrote up to 10 years ago, so we need to maintain support for these old JavaScript kind of code bases. The way it basically works is pretty simple. We've got about 50 scenes. We either lazily load them into the top frame, which is not ideal and we're trying to move away from that, or we put them into iframes and they have kind of an API that talks to the top frame. So when you play a game, it's really one big frame with a tiny little iframe in the middle, which talks to the top frame for certain API things, like when it wants to play sound. This is important because we host the games on a different domain, and that domain doesn't have permissions, so we need to tell the top domain to do things for us. Because you can't, as you might know, if you've got an iframe window, you can't do things in that. Chrome or other browsers won't let you prompt that user for permissions because you're kind of breaking out of your box. Our scenes come in a bunch of categories. They're either locked, which is like the tracker, because you can't play it till the 25th or the 24th. They're either really tightly coupled with the app state, which is like the village, because we obviously show a lot of global state. We say, well, is this house unlocked? Can you play this today? Things like that. Most of our games are largely isolated. We've got a new build system, which is quite nice, because we can test games individually. You don't have to run the whole site. Or they're content heavy. We've got a few kind of mixed up in pages, which ironically we actually like to SEO a whole bunch because they've got things like educational resources or information for press. A bit of history on the site. We've used a framework called Polymer. So I haven't really talked about web components yet, but I want to introduce Polymer as kind of the introduction to web components. So I'll touch on it a little bit more, but I want to just give a really brief history. Polymer was a framework that used web components. We did this in 2014, which is quite a while ago now. Like with all things Google does on the web, we tend to go a bit hard. And so what happened at the time was we needed tons of polyfills. To really use Santa Tracker effectively, you're loading tons of code in most browsers, not in Chrome, but everywhere else, because Chrome is driving forward, building these features, and we have to kind of hack them into other places, which is not really ideal. As we go along, Polymer 1 came out in 2015. It was fine, still had some bugs. This is where the current implementation of Santa Tracker sort of comes from, this kind of playful village that you see here. In the next few years, we wrote a bunch of games. Some of you might have played them. This one on the top is my favorite. It's basically, when we built it, it was called a PUBG clone. Now it's called a Fortnite clone, because apparently the world's moved on and people understand Fortnite more than PUBG. But it's very cute, and that's actually now our most popular game, which is quite nice. You can throw snowballs at 99 other elves until you're the last elf standing. We've also got other cute stuff which you can go and play, hopefully not while my talk is running. In last year, this is where we are now. We use Polymer still. It's version 2 of Polymer. The one really nice thing now is that all those crazy features that Chrome and fundamentally Google pushed for are mostly now there in other browsers. So historically when I've given talks about web components or Santa, I'm like, it's great, but you've got to include this polyfill for Safari and Firefox, and it's fine, I promise you. You don't have to anymore. Certainly for IE 11 and some old browsers, it's still a challenge, but for modern people, all I'm talking about today totally works fine. There's no real issue with it. Polymer, though, is showing its age. It was written, the first version came out in 2013, and I'll get to some of Google's challenges with this in a second, but we're trying to move away from Polymer. So there's nothing wrong with it if you want to use it. It's a great UI library, but it was designed for an earlier time. So now I want to talk about web components. So everyone knows what a web page looks like. Even if you're not a web developer, you've all view sourced on a page. You know that web pages are made up of nodes, which are XML. So they have nodes like header and section, which are used for layout. And you have nodes like the A, which is for links, buttons for clicking on stuff. There's even some more advanced elements that people don't know about, like the dialog, which is a modal dialog, or the details element, which is it gives you a little drop down to open it, expand and close something. Fundamentally, the Web Components API, which is the second part of this talk, lets us write our own elements. You can call them whatever you like. My element is a good place to start, but Santa Tracker is entirely built with these web component things. This isn't really a new concept, right? Like if you ever wrote jQuery and used jQuery plugins, jQuery would look for like the thing that was annotated with the class jQuery UI, something magical, and it would do something to that element. We're not talking about anything that's significantly different than that, but now it's a standard, right? And now I can just drag this element on my page, and things work a lot more. It's a lot more cohesive to development. People roll this up as an example of why we might need web components. So if you look at Gmail's source code or Gmail's live DOM representation, it looks like this. It's kind of a bit mean, right? Like this is Gmail, obviously lots going on under the hood, but in essence, Gmail doesn't look like, its source code doesn't look like Gmail, right? It's this huge mess of stuff. It's really being used as a render target for the web. Gmail has this internal representation, which obviously is reasonably complex, and it then still looks like an email client. That's not the issue. But if you were to look at the source code, this is really hard to rationalize about. What we could do with web components, hypothetically, is change this layout completely. And when you inspect the page, when you look at the page, it could look like this. You could have a header with the Gmail search element, which has got the search bar. You could have a sidebar with a compose button and some links. And it could have some messages in the middle. And the way we do this is we then turn this into a better representation. Each one of these elements is actually not just text. It might have UI representation, it might be the bar that the message is in, it might be the compose button, which has got a bunch of UI around it. But we can wrap this behavior up in these elements. This code's a bit long. I wasn't sure if I was going to keep it here, but this is like a really minimal version of what that message might look like. So the DOM is still there, right? I'm not saying that you can't hide from the fact that in the end, the Gmail thing is made up of divs and this kind of stuff that might be quite hard to rationalize about, but it lets you write a page in the foreground, which kind of looks sane, right? Whether you want that is a whole different discussion, which I'll get to in a second. Why do we want web components? They're not for everybody, right? HTML is semantic, right? If you have a screen reader, it's going to look at any HTML page and go, cool, that's a form, that's a link. I can tab between things. So HTML has meaning. It's not just divs and kind of like a canvas you draw to. But the question I have for the audience, and the question that's kind of, to be honest, it divides the world between like the React model versus the web components model versus some stuff in the middle, is HTML just your render target? Is it something you just dump nodes into? You've got this complicated state like Gmail, and you want to render it to a user. You can do that with a million divs, which is fine, but it means that you kind of have no real sense of what your HTML is really doing. You can't really rationalize about it or do anything sensible kind of on the client side. You're kind of generating this huge mess of stuff, which does work, but it has its own challenges. Web components let you add a little bit of semantics and structure to any higher level concept you want to represent. So whether it be a message or a button or whatever. People sort of say to me, well, web components, isn't this just a Google thing? I kind of hinted at this before. One of the problems Google has is that we shipped Polymer in 2013. And so if you ask someone a few years ago, or even now, what's web components? Some people will say, well, isn't that just Polymer? And unfortunately, that's kind of the legacy we've got to deal with. Because Polymer was really so early in this game, what Google tends to do is, we have this new great concept. Google's worked with the standards bodies to introduce web components and the things we need to support web components. And we've shipped a library along with that. But along that time, in the intervening time in the last 6 years, other browsers have come to the party, which is great. We've kind of ended up with a slightly more constrained version of Google's sort of vision, or the thing that people, on the spec bodies, which weren't all Googlers. So, we have this challenge where we're trying to fight against the fact that Polymer is not web components. This is the only negative slide I have, but it's just this challenge of, if you've heard of Polymer, if you've heard of web components, what I really want to say is they're just not the same thing, and there's something we're trying to get away from. I want to talk a little bit about Santa Tracker. I've given you some kind of Gmail examples, but let's look specifically at Santa. So we have this element at the top here. So this little score picker thing is actually, under the hood, something like this. So all we really do is we create this Santa score element, which is really nice for us, right? We don't have to stamp out all these nodes whenever we want to render score. We literally just say, here's a Santa score element, go and render it. And that looks like what you would expect, right? It's got some attributes, it's got a level, it's got a total level, it's got a game. That game might represent the icon that's being displayed there. And we can reuse that element wherever we like. Admittedly, we only use it once, but we can stamp it out whenever we want. And it kind of just comes with all its functionality for free, which is really nice. In the end, web components, and I've talked a bit about Polymer and a few negative things, but in the end, web components let you describe elements that are first-class citizens. I can create my-anything or foo-bar or Santa-button, and I can use that in my page wherever I like, regardless of the framework I'm using or regardless of the technology stack I'm building on. And that just becomes a thing in your page that has a high-level meaning. I could spend 2 days on running a course on all the different things you could do with web components. But the classics are things like buttons or UI widgets. What gets more tricky is when you have things like components that don't look like anything, that just help you lay out your page and do routing and things like that, which I won't get into, but it is possible. The most important part of web components is really the shadow DOM thing, which I kind of hinted at, but haven't really mentioned directly. So this is the real magic of web components. I can create that element, that Gmail message, or in this case, a Santa button. And this doesn't look like, this shadow root thing here doesn't really appear on my page. It's still there, right? I've got to define what the element looks like and the structure it has. But you see here, I can create an element that's basically just a glorified button, but it has its own style. It's encapsulated. That X element that describes my button doesn't break out of the scope. It's just going to show this button here, and we have a special element here called slot, where this text will actually end up going. So slot is kind of magical in our little world, where we can create this hierarchy, and basically anything we've put inside the button itself appears in this magic place like a wormhole. I don't want to go into too much of the syntax. It's all on the web. You can do a bit of searching, but this is kind of the simplest example I could come up with. Everyone starts with a button. It's the easiest thing to do. Everyone wants pretty buttons, and everyone hates using HTML to do it with one element. So having the ability to add 10 nice little divs that do nice UI things is always really appealing to people. I hinted at this before. Browser support is really fine. It turns out Edge is kind of going away because we're now getting Edgeium, which is based on Chromium. Ironically, if I give a talk next year, I'll be up here saying, it's great, everyone uses Chromium, but also IE11 is still out there, so good luck. To put it another way, everyone's happy now. I'm quoting my colleague Rob here. Everything is great and everyone has totally agreed up to this point. But like I said before, it's 2019, even in 2018 last year, my talks were simple. I could just say, well, everyone agrees, it works. It's been a long road getting here, which is kind of me being exasperated, but actually all the stuff I'm talking about today works fine, and all the major browsers are pretty happy to support it. And like I said, these things work now, right? As a sign of like how prevalent web components are, there's a bunch of different frameworks out there you can use that have a ton of, all this stuff on the top left is some really nice UI stuff people have built that you can just go and use in your projects. There's a CSS tricks article which seems to be hitting the mainstream, so you can just Google how to use web components and there's a bunch of articles about it. I don't have to put tons of links up or anything, you can just search for them, they just work. I want to talk about where we use them in Santa. We have this info card here which wraps up a bunch of behavior to do with this picture and the press resources and things like that, which is quite nice. We've got a button, which as you would expect. So this button is made up of not just one div, but a whole bunch of things with a button under the hood. But it means we have this nice push button with a cute little shadow effect. So that's provided by a web component. This is one I'm quite proud of. The first game on Santa Tracker, I think it's in the top left, is a thing called Elf Maker. So you can kind of see the elf hiding at the top there. But the Elf Maker control structure is actually a bunch of custom elements, web components rather, stuck together. We've got the whole thing is a maker control, but it contains a chooser, which literally I wrote because it contains things that are circles you can click on, which are the two things at the top. And then you have this kind of choice thing, which it's got a bad name because we're bad at naming things, but under the hood, all it does is put a bunch of different SVGs on elf heads, which is what you do want to do when you want an elf to be different. So, if you click the glasses button, you get glasses on elf heads. If you click the hair button, you get hair on elf heads, because it turns out that's how you customize elves. And we also have things like Santa state, which is actually a hidden element, which all it does is connects to our backend and listens for when Santa's taking off. Amusingly, this is not constant because we actually skew everyone's experiences of Santa slightly differently. Many years ago, Google Maps was very nervous about us overloading the servers. So if you load two browsers, both loading Santa Tracker, you'll see Santa taking off plus or minus 2 minutes. And so the idea there is we don't overload any particular part of Google Maps because everyone's looking at the same thing at exactly the same time. So when when your kids look at some website and say, why is Santa taking off earlier and later, and why is he in a different place? just say it's we're slowing him down for your benefit. I'll kind of skip over this a little bit, but we also have our lazy loading code. This is from an old slide deck, so I've left it in. This basically is an element which looks at the current route, it looks at the URL in the URL bar, and it loads the code for that. So which is quite nice. So we actually go Inception style. Each game is actually a custom element as well, and so what we actually do is we just don't create that custom element until it's ready. The browser just thinks it's this random thing it can't render until that scene is loaded. And when it does get loaded, it magically goes, cool, I can render this now. Here you go. And the last example I want to show off is this cute little GIF of the reindeers. These little reindeers, which you can find if you look really hard on the front page of Santa Tracker, not on mobile, sorry, we hide them. But this is literally a web component. It's a bunch of divs and a bunch of CSS animations that we wrap up nicely in an element. So if I wanted to, I could just put this 100 times everywhere you like. I probably wouldn't, but that's something we could do. And it's quite nice because we literally can wrap up this behavior in something we can just use wherever we want. It doesn't leak. The reindeers aren't going to change the color of some of that element if I change their nose color. It's just a nice little thing that we can share with other people. We're also bad at naming things. A web component needs to have a dash in it. It doesn't matter what you call on the left, what is on the right. But probably we should be calling these like Santa, Easter egg, reindeer, not reindeer wrangler, because it's very confusing. But as I've already mentioned many times, we're really bad at naming things. So that's some examples of web components and how we use them. Some of our goals for 2019. I've kind of hinted at this already. We're not huge fans of Polymer anymore. There's nothing wrong with it. It actually has a huge UI library that we don't really use, which is one of the reasons we might not stick with it, because we have a kind of own UI look and feel. We want to use native custom elements as much as possible, not with a framework on top, but we want to use a thing called lit element where we need to do something tricky. If you were curious, I wrote an article last year on Christmas called The Gift of Giving Up, which basically talks about the fact that the goals for this year are exactly the same as last year, we just didn't get time. So it was a lovely article about how we just stopped doing development and just shipped the old thing and no one noticed, which was great. So you don't always need to ship new things. Why am I using lit element? To be perfectly honest, it's because it's written by Google, and we think it's great. But what we think you should do if you're using web components is you should pick a library that you like. There's quite a lot of them. A good friend of mine writes one called Skate.js. There's Ionic. There's a few different libraries you can Google for them. But we think using more than one is a terrible idea. But one of the reasons we like lit and some of these libraries now is that if you don't need them, you don't use them. So you probably haven't written web components before, it's a pretty safe bet to say, but you might write some really simple vanilla ones. Like if you just have a button, you don't need crazy two-way binding and state representation and management. It's just a button. You just write some HTML, you dump it in the element, it looks nice, it works really great. You don't need to use a library for that. So while we use lit for some complicated stuff, the best thing we found about it is that it doesn't make you use it when you don't need it. And so this is a really good part of a library that we like. And so it looks a bit like this. If you're using TypeScript, it's actually a bit nicer because it's got like those weird at decorators, but I'm not really a huge TypeScript user, so this is what a lit element might look like. It's got a properties function to return the things it cares about, and then you render it with a function called HTML. And it does kind of magical, not VDOMing, but like similarly efficient updates when things change. So if you change the color, it doesn't re-render the whole DOM, it just changes the color, which is really nice. This is one of my last slides. Every man and his dog, every woman and their cat has an opinion on web components. You'll read people who love them. You'll read people who hate them. You'll read people who think they're the worst thing Google's ever done, even though it's part of the spec, and Safari supports them now too. You'll hear people say, use React, it's the only way forward. I don't really care about all the stuff. Like, I don't actually want to get into any of the debates. The thing for us is that web components are this primitive that's in the web. Some people will use them directly. There's some frameworks that actually output to web components. You don't even know that that's under the hood. Like Angular, to some extent, uses web components quite heavily. You create these foo-bar elements, but it's not really what they sell Angular on. There's one library I mentioned before, Ionic, with their UI library. It has a web components version, it has a React version, it has, I think, 2 other versions of some other frameworks. You might use this up directly, which is great, and for Santa Tracker, we do want to do that. But you might use this without even knowing, which is really nice. And the thing is, it's in all these browsers right now, so they're here now. We want to use them extensively, but maybe you want to use them for other things. I mentioned Angular already, that's on the slide here, but another really cool use case, which you probably don't know that you're using already, is GitHub's, I think they're so when you look at a file, it says this has changed 7 days ago. So that's interesting, right? How do you render that on the server? You don't want to cache that page for a week because then it's out of date. What they actually do is send the absolute timestamp in that field. And that's actually wrapped in a web component. And that web component, as soon as it starts, it's GitHub-datetime or something, I forget what it's called, it will start up and replace its own content with a relative date. So the version in your cache has never actually got that relative date in it. So it's a really small, subtle use case for a web component, even though the page itself is pretty traditional, right? You can load it on any browser, it clicks around, doesn't really have that much JavaScript in it. It's a really interesting use case for a web component that you probably used every day and you haven't even thought about it yet. And it's all because it's now part of the spec and they just work. And that's my talk.